All right, so if you're given other data such as IR or mass spec data, or if you're just given the overall formula, oftentimes that can be enough to deduce your compound of interest to one of multiple things, right? So, for example, if we have C3H7Cl, right, that's our chloropropane, right? There's only really two ways to organize this. Either the chlorine can go on the one position, or it can go on the two position. There's no other kind of constitutional isomers that can occur. And so you don't actually have to take a real good look at the splitting patterns or anything. You can deduce this from simple symmetry, right? If you think about it, this one will have these two protons will be different than these two, which will then be different than these three, right? So overall, you should see three peaks. So if you have this formula and you see these three peaks, you should be able to automatically go to, oh, that's one chloropropane. Whereas this compound has an element of symmetry. And so here we'll only see two peaks. So symmetry is extremely useful in both proton NMR and even so in carbon NMR, which we'll learn about in a bit. So always keep an eye out for symmetry. All right, what if you deduced your compound to one of these three or one of these two? Right? In both of these compounds, we have the same thing. We would expect to see a 9H singlet corresponding to the tert-butyl group, and then a 3H singlet corresponding to this methyl group, right? And so looking at the number of peaks won't help you here. Looking at the splitting of the peaks won't help you here. And so how would you deduce what your spectra is going to look like, right? So remember the other pieces of information that you can get from an NMR, and one of them is the location of the peaks. So if we take a look at our compounds right here on this side, we have this methyl right next to this oxygen, whereas here this methyl is not next to an oxygen. And so by looking up our peak data, we can identify which compound this is going to be, right? If it's this compound over here, then we're right next to an oxygen, and so it'll be approximately from about 3 to 5 ppm. That's the location of our methyl peak. And then if our methyl peak is on the other side of this carbonyl, then we know it's not going to be shifted as much, right? That's only going to be about 2 to 3 ppm. So if you've got it down to the fragments and now you're just deciding where do I put what, make sure to use the location of your peaks to help you.